So, welcome back everyone from lunch. My name is Steven Spector. I'm the Zen.org community manager. So you may see my name on the blog or all sorts of things. If any of you want to talk about the community, maybe not the technology, but the community, you're more than welcome to stop by today or tomorrow and talk to me. I'm always looking for new ideas. So anyway, I'll be the, guest MC, but I'll be doing the introductions for today for all the different speakers. And we have plenty of time to go through a lot of content, and if you have questions, I'm not sure how it usually works, but feel free to stand up and ask questions, and I can always run around with the mic. And I apologize for my Chinese pronunciation, but I will do my best. So from Intel, speaking on graphics Passthru with BTD is Weidong Han.
My name is Lin Weidong from Intel Open Source Technology Center. Lin Weidong from Intel IT Flex. I will talk about the graphic Passthru in VTD. Here is the agenda of this presentation. Firstly, I will simply introduce the graphics virtualization. Then I will talk about the graphics Passthru, and we'll talk about the challenges and our solutions for this challenge. After that, I will show the performance of graphics Passthru, and you can see it can achieve very good performance. Finally, there are a few key points of this of graphics Passthru. Why need graphics virtualization? In this morning, you already see the Ian showed the demo. You can see in the virtual machine can make use of 3D capabilities. It's very cool. The answer is obviously people want to use powerful graphics capability in virtual realization environment. People with these capabilities, people can play 3D games or something, or can watch high definition videos, and also can make use of this capability to do some engineering jobs, such as CAD, something like that. This is a requirement of the graphics virtualization. So then we will talk about some approaches of the graphics virtualization. The first one is device emulation. This approach is emulate a physical graphics device. The advantage of this approach is it can provide the virtual device to multiple guests. But the disadvantage is also obvious of the software emulation. It has a high overhead, and also it's difficult to emulate a graphics device. You know, the graphics device is very complicated, and what's more, it's hard to get its technical documents usually they are not public. So this is the issue. The next is API remoting. This approach will wrap high-level API, for example, OpenGL or D3D API, and forward the API calls from guest to host graphics stacks, and then will be handled in the host side. The high-level API is not dependent on the underlying hardware, so this approach is hardware independent. But this approach needs additional software stack in the guest. Usually it needed to change the driver in the guest to forward the API to the host. The third one, we will talk about the graphic passthrough. This approach is assign a physical device to the guest and let the guest to directly access the graphic device. Because it can directly access, so it can it have good performance, and also it needed to change anything on the guest graphic stack. It can just use the native driver in the guest, so it don't require any GPU programming knowledge. But Passthru has a limitation. That is that's the other guests cannot access the advanced device in this guest because this guest the access is exclusive in this guest. This presentation is focused on. We will talk about the passthrough approach. More details next. And before introduce the graphics passthrough, I will simply introduce the general PCI passthrough with VTP. You can see. So you can see PCI passthrough in short is just assign the physical device to a guest, and the guest can use its native driver and can directly access the physical device. But you need to know how to make it can directly access. In the guest, the driver uses the guest address, but the physical device cannot use the guest address directly. So there is need address translation. Intel VDD technology can provide this address translation, so can make it directly access the device. And the performance is good, and also can provide good device isolation. Next, the general PCI passthrough cannot support the graphic passthrough because there are some special challenges. The first one is like the legacy VGA. It's inherited from past. The VGA resource, the I/O ports and the memory range are not on the device. They are at a fixed address in the system memory. So how to make the advanced device in guest to use VGA? This is a challenge. The next is about the